In a world increasingly aware of the interconnectedness of Earth's systems, a groundbreaking approach to geophysics is emerging, one that emphasizes the vital interactions among the solid Earth ocean's atmosphere and biosphere. This paradigm shift is encapsulated in the new textbook Earth System Geophysics, recently released as part of the American Geophysical Union's Advanced Textbook Series. As the field of geophysics evolves, this comprehensive resource aims to equip upper-level students with the mathematical and physical tools necessary to understand the complexities of our planet. Historically, the study of geophysics has primarily focused on the solid Earth, examining the crust, mantle, and core, and has largely centered around plate tectonics. However, as the author of the textbook Stephen R. Dickman explains, this limited perspective fails to account for the geophysical behaviors of the oceans and atmosphere, which are driven by similar convection processes. Studying the solid Earth alone would be incomplete if we ignore interactions with the rest of the Earth system, he notes. This Earth system perspective not only broadens the scope of study but also provides a more holistic understanding of natural processes. The textbook is structured in two main parts. The first delves into the Earth system science framework, discussing the planet's origin and atmospheric evolution, while the second part focuses on convection-driven phenomena such as gravity seismology and geomagnetism. This dual structure is designed to foster a comprehensive understanding of geophysics in the context of Earth system science. The text is specifically tailored for geology students at the senior undergraduate or beginning graduate level with prerequisites in calculus and physics. Given its extensive content, instructors are encouraged to utilize it over a 2-semester course. Although selected chapters can be adapted for shorter focused courses on topics like climate change or traditional solid Earth geophysics, the approach aims to instill confidence in students who may initially find the mathematical rigor daunting. Dickman emphasizes that the book introduces mathematical concepts, gradually pairing qualitative interpretations with quantitative analysis to build understanding progressively. One notable feature of the textbook is its interactive design, which includes stop-and-think questions that encourage readers to reflect on the material and connect it with prior knowledge. Additionally, the textbook is enriched with color figures and a comprehensive reference list, underscoring the importance of peer-reviewed research in the scientific process. In an era when the validity of science is frequently questioned, these citations highlight that science is not merely a narrative but a synthesis of independent results, Dickman asserts. As the field of geophysics continues to evolve, the significance of Earth system science becomes increasingly apparent. The recognition of convection as a unifying theme across various Earth components fosters a deeper understanding of the planet's behavior and the interactions that govern it. Earth system geophysics represents a critical step forward in teaching this integrated perspective, equipping the next generation of scientists with the skills necessary to tackle the pressing challenges posed by climate change and resource management. In conclusion, as the scientific community embraces this Earth system perspective, the implications for future research and education in geophysics are profound. By fostering a more inclusive understanding of our planet's systems, educators and researchers can contribute to a more sustainable future, ensuring that the lessons learned from this interdisciplinary approach resonate in classrooms and laboratories for years to come. The journey toward a comprehensive understanding of Earth's complex systems is just beginning. And Earth system geophysics is poised to lead the way. In a recent study, Yale University experts have raised concerns about a new condition linked to COVID-19 vaccines termed Post-Vaccination Syndrome (PVS). This syndrome is characterized by a range of distressing symptoms, including chronic fatigue, dizziness, and brain fog, along with significant biological changes that persist long after vaccination. The study's findings have ignited a wave of anxiety and anger among the public, particularly among those who received COVID vaccines, as it suggests potential long-term health ramifications. Dr. Akiko Iwasaki, a leading author of the study, emphasized the preliminary nature of the research, stating this work is still in its early stages, and we need to validate these findings. But this is giving us some hope that there may be something that we can use to treat PVS down the road. The study involved analyzing blood samples from 42 individuals diagnosed with PVS, comparing them to a control group of 22 individuals who had been vaccinated but did not experience adverse symptoms. The results indicated that those suffering from PVS exhibited altered immune cell proportions and elevated levels of COVID spike proteins years after vaccination. Moreover, the research uncovered a link between PVS and the reactivation of the Epstein-Barr virus, a dormant virus that can cause flu-like symptoms in many individuals. Dr. Iwasaki remarked on the unexpected presence of spike proteins in circulation, stating that it was surprising to find spike protein in circulation at such a late time point. This revelation suggests that patients experiencing PVS may face ongoing health challenges, potentially exacerbated by the reactivation of latent viruses. The impact of PVS on individuals has been profound. For instance, Sascha Schwartz, a 32-year-old care worker from Germany, described his experience since receiving the AstraZeneca vaccine as one marked by feelings of helplessness and powerlessness. "I feel trapped in my own body," he shared, detailing how symptoms such as fever, dizziness, and persistent brain fog have dramatically altered his quality of life. Schwartz's struggle to find medical acknowledgement of his condition highlights a broader issue faced by many patients whose symptoms have been dismissed by healthcare professionals as psychosomatic. The public response to the study has been largely negative, with many taking to social media to express their disbelief and anger over the potential implications of the vaccine. Comments from users reflect a sense of betrayal and frustration, with one stating, "I can't believe they forced us to take the shot without fully understanding its long-term effects." These sentiments resonate with those who have experienced adverse reactions and have felt unheard during the pandemic. The study's findings are particularly significant in the context of regulatory responses to vaccine safety. AstraZeneca, for example, was compelled to admit, following legal actions related to vaccine-induced thrombosis, that its vaccine could lead to rare but serious side effects. This admission has sparked discussions on vaccine safety protocols and the need for greater transparency in the face of adverse outcomes. Dr. Harlan Krumholz, co-senior author of the study, urged a balanced approach, acknowledging the challenges some individuals face post-vaccination while emphasizing the need for rigorous investigation into patient experiences. Contrastingly, vaccine expert Dr. Paul Offit defended the overall safety of vaccines, noting, "The vaccines have been given to billions of people at this point, and there were large prospective placebo-controlled studies that didn't show these effects." As researchers continue to investigate PVS and its implications, the public's response underscores a growing demand for accountability and support for those affected. The study not only opens the door for further research into post-vaccination conditions but also poses critical questions about the communication of vaccine risks and the responsibilities of health authorities to address emerging health concerns. Looking ahead, the focus will now shift to understanding the prevalence of PVS and identifying individuals at greater risk. The urgency of this research cannot be understated, as it may shape future vaccine policies and ultimately influence public trust in immunization efforts. The conversation surrounding vaccine safety is evolving, and as new data emerges, it will be crucial for health authorities to engage with the public transparently and empathetically to rebuild confidence and ensure that the lessons learned from this pandemic are applied in future public health initiatives. In a world increasingly shaped by environmental policies and scientific research, recent developments regarding the U.S. Environmental Protection Agency (EPA) have sparked significant concern among public health advocates. Jennifer Sass, a senior scientist with the Natural Resources Defense Council, articulates the dire implications of the Trump administration's decision to dismantle the EPA's Independent Research Office, a move she argues could exacerbate pollution and its associated health risks, particularly cancer. The EPA has long been regarded as a guardian of public health tasked with enforcing critical regulations under statutes like the Clean Air Act and the Safe Drinking Water Act. However, the recent announcement to eliminate over 1,000 scientists and technical experts threatens to cripple the agency's ability to evaluate the risks posed by hazardous chemicals.
SAS notes that the removal of scientific inquiry from the EPA's decision-making processes compromises the integrity of environmental safeguards.
Every major environmental statute relies on EPA scientists to calculate how hazardous chemicals are. She emphasizes, pointing to the potential for increased pollution as a direct consequence of this policy shift. The ramifications of ignoring scientific expertise are already apparent in Texas, where the state has vigorously defended ethylene oxide, a chemical linked to cancer. Following a comprehensive evaluation by the EPA which determined a 30-fold increase in cancer risk associated with this carcinogen, Texas officials and the chemical industry crafted a counter-report that downplayed the risks. This contractor product sponsored by the ethylene oxide industry fails to account for the risk of breast cancer and could allow over 3,000 times more air pollution to be emitted, SAS warns, highlighting the troubling trend of prioritizing industry interests over public health. This situation reflects a broader systemic issue, the growing prevalence of polluter research, which often lacks the rigor and impartiality of independent scientific studies. The Texas case is emblematic of a dangerous trend where industry-sponsored research undermines established scientific consensus, leading to policies that may endanger public health. The recent rebuke of the Texas analysis by the U.S. National Academies of Sciences further underscores the importance of relying on credible scientific methodologies when evaluating environmental health risks. The urgency of these issues is compounded by the ongoing rise in cancer rates and other health complications linked to environmental pollutants. As SAS succinctly states, the future generations will be even worse off if current trends continue unchecked. Erasing cancer evidence and fudging data will become the norm, she warns. Painting a bleak picture of a regulatory landscape increasingly susceptible to the influence of polluting industries. Looking ahead, the implications of these developments extend beyond Texas, as similar actions could undermine environmental protections nationwide. Public health advocates are calling for a re-evaluation of the role of scientific research in shaping environmental policy, emphasizing the need for transparency and accountability in regulatory practices. As the landscape of environmental science continues to evolve, the challenge will be to ensure that the voices of independent scientists are not silenced and that public health remains a priority over industrial profits. In parallel to these environmental concerns, advances in cancer research highlight the potential for innovative solutions in personalized medicine. A recent study from the University of British Columbia showcases a promising new approach to matching young cancer patients with effective treatments by using proteomics, analyzing proteins in tumor samples alongside traditional genomic methods. This research underscores the importance of creating targeted therapies based on an individual patient's tumor characteristics, a strategy that could significantly improve outcomes for children facing aggressive cancers. As we navigate the complexities of environmental and health-related issues, it is essential to foster a dialogue that prioritizes scientific integrity and public health. The path forward will require a concerted effort to protect independent scientific research and ensure that policies are informed by robust evidence, ultimately safeguarding both the environment and the health of current and future generations. As the realm of technology continues to evolve, the intersection of artificial intelligence and healthcare is rapidly transforming how we approach personal wellness. Recent developments indicate a significant leap forward, particularly with Apple's ambitious plans to launch an AI-driven health coach as part of a comprehensive overhaul of its health app set to debut in 2026. Dubbed Project Mulberry, this initiative is poised to redefine personal health management by utilizing data from devices like the iPhone and Apple Watch to deliver tailored health recommendations. The centerpiece of Apple's new endeavor is the AI Health Coach, which will analyze various health metrics including heart rate, sleep patterns, and activity levels. By doing so, it aims to provide users with personalized advice to enhance their fitness, nutrition, sleep, and mental health. This represents our most ambitious effort in the health sector to date, an Apple insider noted, emphasizing the potential impact of this technology on users' daily lives. To ensure the effectiveness of the AI Health Coach, Apple is collaborating with a diverse group of medical experts across multiple disciplines, including cardiology, nutrition, and mental health. These specialists are not only helping to train the AI system but are also creating educational video content that will be accessible within the app. This integration of expert knowledge aims to enrich the user experience, making the health app a comprehensive resource for personal wellness. In addition to personalized health coaching, the revamped health app is expected to introduce food tracking capabilities, allowing users to log meals and receive nutritional insights. This feature positions Apple in direct competition with existing platforms like MyFitnessPal and Noom, potentially reshaping the landscape of dietary tracking. The AI coach will assist users in maintaining detailed dietary records and offer meal suggestions tailored to their nutritional needs. Moreover, Apple is developing camera-based features that will utilize the iPhone's capabilities to analyze users' workout techniques. This innovative approach aims to provide real-time feedback on exercise form akin to having a personal trainer, thereby enhancing workout effectiveness and minimizing the risk of injury. Apple's strategic overhaul of the Health app may also involve rebranding it as Health Plus, hinting at a possible subscription model that could offer premium features. While it remains unclear whether the AI health coach will be part of a subscription package, the rebranding suggests Apple is looking to expand its service offerings significantly. This ambitious project aligns with Apple CEO Tim Cook's vision of healthcare as a cornerstone of the company's legacy. Under his leadership, Apple has increasingly focused on integrating health features into its products, building upon years of advancements in health technology. The AI health coach's development is overseen by a dedicated team led by Sumbul Desai, with strong support from Chief Operating Officer Jeff Williams. As development progresses full steam ahead, the anticipated release of these features with the iOS 19.4 update in the spring or summer of 2026 reflects Apple's commitment to pushing the boundaries of digital health innovation. While challenges related to the accuracy of AI advice and the complexities of health data privacy remain, this initiative signifies a pivotal shift in how technology can empower individuals to take charge of their health. In a broader context, Apple's move into AI-powered health coaching underscores a growing trend toward personalized data-driven solutions in technology. As the capabilities of AI continue to expand, the potential for such innovations to redefine user engagement with personal health data is immense. Looking ahead, it will be fascinating to observe how these advancements will not only enhance individual health management but also influence the overall landscape of healthcare delivery. Recent satellite imagery has unveiled a significant development in the global nuclear fusion landscape. China is constructing a massive laser-driven nuclear fusion facility in Mianyang that is reported to be 50% larger than the National Ignition Facility (NIF) in California, currently the world leader in laser fusion research. This ambitious project not only underscores China's intent to dominate in clean energy production but also raises strategic military implications that could alter international power dynamics. The imagery analyzed and reported by Reuters presents a striking picture of a facility designed to harness the potential of nuclear fusion, a process that aims to replicate the reactions fueling stars by focusing powerful laser beams on hydrogen isotopes. This method promises a clean and virtually limitless energy source, which aligns with China's broader goals of reducing fossil fuel dependency and achieving energy independence. As noted by a representative from the Chinese research community, this installation could become the centerpiece of this long-term energy strategy, reflecting a commitment to advancing its capabilities in cutting-edge technologies. China's pursuit of this megalab is not merely about energy production, it also has considerable military implications. According to Decker Eveleth, a researcher at the CNA Corporation, the capability to simulate thermonuclear explosions through laser fusion could provide critical data on nuclear weapon behavior without the need for live detonations. Laser fusion allows for the precise simulation of thermonuclear reactions, Eveleth explains, highlighting how this dual-use technology could bolster China's military prowess while simultaneously positioning it as a leader in energy technology. The timing of this development is particularly noteworthy given the competitive landscape of fusion research. Recently, The NIF achieved a historic milestone by generating more energy from a fusion reaction than it consumed, a first in the field.
China's rapid advancement in constructing a facility that surpasses the NIF in size signals a determined push to cross new frontiers in fusion technology.
This escalation in efforts has not gone unnoticed by other nations, notably France, Russia, and the United Kingdom, all of which are closely monitoring China's advancements as they continue to develop their own nuclear fusion capabilities. Amid this growing global fusion race, there is a palpable tension regarding whether the scientific challenges posed by fusion will be met through collaboration or rivalry. While the complexity of fusion research suggests that no single nation can achieve breakthroughs in isolation, the competitive atmosphere may serve as a catalyst for innovation.
As articulated in a recent report, rivalry stimulates innovation.
Though it remains to be seen whether this will ultimately lead to a collaborative approach that benefits all parties involved. In parallel, innovations in fusion technology are also emerging from smaller players in the field.
A notable example is the Israeli startup Metatron NRG, which is developing a nuclear reactor no larger than a desktop computer.
This groundbreaking approach utilizes a unique form of nuclear fusion involving stable plasmoids, compact bundles of superhot plasma, which could revolutionize the energy landscape by providing a cost-effective, scalable alternative to traditional energy sources. Co-founder Dr. Yeshayahu Eisenberg emphasizes the transformative potential of their technology, stating, "By solving core stability challenges, we are paving the way for small-scale fusion reactors that could revolutionize energy generation." As the fusion narrative unfolds, the U.S. is not standing still.
The Department of Energy's Oak Ridge National Laboratory (ORNL),
led by Fusion Energy Division Director Troy Carter, is actively engaged in advancing fusion research. Carter emphasizes the importance of collaboration across various sectors, stating, "Fusion is one of those challenges where you need to have all hands on deck." His vision for ORNL as a hub of fusion innovation underscores the necessity of integrating public and private efforts to commercialize fusion power while fostering fundamental research. As nations and companies alike race to master nuclear fusion technology, the implications for energy production, environmental policy, and even military capabilities are profound. Should these ambitious projects like China's Megalab or Metatron's compact reactors succeed, they could reshape the global energy landscape, influencing market dynamics and geopolitical strategies well into the future. In a world increasingly defined by the intersection of technology and power, the quest for fusion energy embodies both the promise of innovation and the complexities of international competition. The coming years will be crucial as the fusion race continues to unfold, potentially heralding a new era in energy generation and global relations. In a remarkable leap forward for the field of materials science, researchers are inching closer to the long-sought goal of room temperature superconductivity. A recent study from scientists at the California Institute of Technology Caltech has unveiled a novel state of superconductivity known as Cooper pair density modulation (PDM). Although this discovery does not directly yield a room temperature superconductor, it significantly enhances our understanding of high temperature superconductivity, paving the way for future breakthroughs. Superconductors, first discovered over a century ago, are materials that can conduct electricity with zero resistance. A property that has led to transformative technologies such as magnetic resonance imaging (MRI) and particle accelerators. Traditionally, these materials only exhibit superconductivity at temperatures near absolute zero, which limits their practical applications due to the need for extreme cooling. However, incremental progress has been made with certain materials like copper oxide showing superconductivity above 130 Kelvin (-225 degrees Fahrenheit). The ultimate goal remains to identify a superconductor that operates at room temperature and ambient pressure, a holy grail in the field. The recent work from Caltech's international team introduces PDM, which describes how the energy gap necessary for superconductivity can vary at an atomic scale within a material. Lead author Lingyuan Kong highlighted that their findings represent the strongest reported gap modulation so far, suggesting that understanding this phenomenon could lead to new superconducting phases. Senior author Stephen Nachpurge echoed this sentiment, stating, "Understanding the mechanisms leading to the formation of superconductivity is driven by this ultimate dream of achieving room temperature superconductivity. The research builds upon the concept of Cooper pairs of electrons that form at low temperatures and move through a lattice without scattering. In this study, the researchers observed that the modulation of the Cooper pair density could occur on a wavelength comparable to the atomic structure of the superconducting material, which they investigated using scanning tunneling microscopy. The team used an iron-based superconductor to demonstrate this effect, noting that the PDM state could potentially extend beyond the specific material studied. While the discovery of PDM itself does not yield a room temperature superconductor, it opens up new avenues for exploration. As Nachpurge pointed out, the better we understand the mechanisms behind superconductivity, the closer we get to discovering new materials that can operate at room temperature. In another significant advancement, researchers at the National University of Singapore have synthesized a copper-free superconducting oxide SMUCANIO2 that operates at around 40 K-233 degrees Celsius under ambient pressure. This breakthrough challenges the long-held belief that copper is essential for high-temperature superconductivity, suggesting that the scope of potential superconducting materials is broader than previously thought. The implications of this copper-free superconductor could lead to more efficient electronic applications across various industries. In a different yet equally exciting development, a team led by Chutech has successfully realized a 3-site cation chain using semiconducting quantum dots. This research demonstrates enhanced stability of Majorana zero modes, which are critical for topological quantum computation. The scalability of these cation chains could lead to advancements in quantum computing technologies, a field that is rapidly evolving with the promise of revolutionizing information processing. Furthermore, a team has reported a field-free Josephson diode effect in van der Waals junctions composed of 2HNBC2 thin flakes. This discovery allows for non-reciprocal transport without the need for external magnetic fields, making it a promising candidate for superconducting electronics in quantum devices. As these findings continue to emerge, they signal a burgeoning era of innovation in superconductivity and quantum materials. Researchers remain optimistic that ongoing investigations will eventually yield practical applications of room temperature superconductors, presenting opportunities for advancements in energy technologies, medical imaging, and beyond. The journey toward this scientific holy grail is far from over, yet each breakthrough brings us one step closer to unlocking the full potential of superconducting materials.